Everyone thinks the ultimate home battery is lithium. That's wrong, or at least dangerously incomplete. And I'm not talking about some fringe theory. I'm talking about a principle that engineers have known for decades, that utility companies quietly use at industrial scale, and that most homeowners will never hear about because the loudest voices in the energy space are trying to sell you a $10,000 box on your wall. So before you finance a battery system, before you sign that solar package, before you believe the salesman who tells you that sleek lithium panel in your garage is the smartest thing you can do for your home energy bill, stay with me for the next few minutes. Because what I'm about to show you might change the way you think about energy storage completely. Here's the question nobody asks. What is your home's biggest energy problem? Not your phone, not your laptop, not your refrigerator running through a blackout. For most households in America, the biggest energy drain, month after month, season after season, is heat. Hot water, space heating, air conditioning, thermal comfort. That's where the money goes. That's where the kilowatt hours disappear. And here's the thing that should stop you cold. Water can store that energy directly, without inverters, without battery management systems, without rare earth minerals mined from the other side of the planet. So in this video, I'm going to show you exactly where water embarrasses lithium, exactly where it completely fails, and why an ordinary tank sitting in your basement may be closer to a real home battery than the expensive box everyone on YouTube is telling you to buy. Let's start with the myth. When most people hear home battery, they picture lithium, a power wall, a sleek rectangular unit mounted in the garage, something that charges from your solar panels during the day, then powers your lights and appliances at night when the sun is gone. That's the image. That's the product the industry has spent billions of dollars building into your imagination. And to be fair, lithium is genuinely good at what it does. It stores electricity. It delivers electricity. It holds a charge efficiently. If you need to run your TV during a blackout, lithium is your answer. But here's the problem with that framing. When we say home battery, we've been trained to think only about electrical storage, stored electrons, voltage sitting in a chemical cell waiting to be discharged. And that works fine if electricity is your actual problem. But what if electricity is not your actual problem? What if the real problem, the one costing you the most money every single month, is temperature? Heat in winter, cool air in summer, hot water every morning? What if the biggest waste in your home is not electrons, but thermal energy that you're generating at one moment and immediately losing because you have nowhere to put it? That is the question that opens the door to something most homeowners have never considered. Here's the big reveal, and it's simpler than you think. Water stores energy as temperature, not as voltage. That's it. That's the whole concept. When you heat water, you're not just making it warm, you're loading it with energy, real, measurable, usable energy that it will hold for hours. And because of water's physical properties, it holds that energy better than almost any other common material. Scientists call this specific heat capacity. It's basically a measure of how much energy a material can absorb per unit of mass before its temperature rises. Water has an unusually high specific heat capacity, roughly 1 calorie per gram per degree Celsius, or about 4,186 joules per kilogram per degree Celsius. That number doesn't mean much until you compare it to other materials. Concrete, about a third of water's capacity. Brick, similar. Rock, even lower. Steel, significantly lower. Wood, lower still. Water can absorb and hold more than twice the thermal energy per unit volume compared to concrete or brick. That means a tank of hot water is not just a tank of hot water. It is a dense, efficient, extraordinarily cheap thermal battery sitting in your home right now. Engineers have been exploiting this for decades. Commercial buildings use chilled water tanks to store cooling capacity overnight when electricity is cheap, then release that cooling during peak daytime hours when electricity is expensive. Power plants use hot water and steam accumulation systems. Geothermal installations use underground water loops as seasonal thermal storage. The physics is not new. The residential application is just criminally underused. So let's talk about where water actually beats lithium. Not in theory, in real household situations. Scenario 1, hot water on demand. Your water heater runs every morning. Most of them run on resistance heating, which is one of the least efficient ways to use electricity. But even with a heat pump water heater, the timing matters. If your hot water heater is pulling peak rate electricity at 7 in the morning when everyone is showering, you're paying top dollar for every gallon. Now imagine instead that you program your water heater to run at 2 in the morning, when electricity rates are lowest, or when your solar panels were overproducing earlier in the afternoon. You heat 80 gallons, 120 gallons into a well-insulated tank. That water holds its temperature through the night. By morning, you have a full tank of hot water that cost you a fraction of what peak rate electricity would have. You used a tank of water as a time shift battery for your thermal energy. No lithium required, no inverter, no battery management system. You bought the energy at the cheap hour and stored it in water until the expensive hour. That is exactly what a battery does, just without the chemistry. Scenario 2. Radiant floor heating or hydronic systems. In parts of the country where winters are serious, radiant floor heating is one of the most comfortable and efficient systems available. Water runs through pipes beneath your floors or through radiators, releasing heat slowly and evenly. If you connect that system to a thermal storage tank, what some engineers call a buffer tank, you can heat that tank during off-peak hours and let it release warmth into your home for hours afterward. You're shifting when you buy energy, storing it as hot water, and releasing it as heat when you need it. That's thermal load shifting. It is what a battery does. And a 500-gallon insulated tank of water at 140 degrees Fahrenheit, that's 60 degrees Celsius, stores an enormous amount of energy at a cost that makes a lithium backup battery look financially absurd by comparison. Scenario 3. Cooling storage. In hot climates, air conditioning is the biggest energy bill of the summer. Some homeowners and small businesses are now using ice or chilled water tanks to do the same trick in reverse. You run your chiller or heat pump at night when electricity is cheap and temperatures are lower, which also makes the cooling equipment more efficient since it's not fighting 100 degrees Fahrenheit, that's 38 degrees Celsius, outdoor air. You store that cooling as chilled water or ice. During the heat of the day, you release it through your cooling system without running your compressor at peak rate. Again, same concept. Buy energy cheap. Store it in water. Use it when energy would cost more. This is where lithium simply cannot compete on cost. A lithium battery system capable of shifting even a moderate air conditioning load through a hot summer afternoon would cost many thousands of dollars. An insulated tank of chilled water can accomplish a significant portion of that shift for a fraction of the price. Now, and this is important, I am not going to pretend water is the answer to everything. It's not. And any channel that tells you it is selling you something. Here is exactly where lithium still wins. Completely, without argument. Power outages. If the grid goes down and you need to run your refrigerator, your lights, your medical equipment, your internet router, your laptop, you need stored electricity. Water cannot power a light bulb. A thermal tank cannot run your oxygen concentrator. A hydronic buffer system cannot charge your phone when the grid is down. Lithium wins this scenario, full stop. Electrical appliances. Anytime the end use is electricity, and the majority of your home's appliances do require electricity, lithium is the appropriate storage medium. You cannot convert stored thermal energy back into electricity at the home scale without expensive and inefficient equipment. So if your goal is backup power, running appliances off solar overnight, or islanding from the grid entirely, you need electrochemical storage. You need lithium or its alternatives. Compact situations. If you have limited space, a lithium battery is far more compact than a water storage system of equivalent energy value for thermal applications. A power wall is roughly the size of a large suitcase. A meaningful hot water thermal storage buffer might require a tank the size of a water softener or larger, plus insulation, plus plumbing integration. Portability and scalability in electrical terms. Lithium scales elegantly with solar panels for electrical offset. If you want to maximize your solar self-consumption for all electrical loads across your home, lithium is still the cleaner system. So the honest answer is, lithium and water are not competing for the same job. The confusion happens because the marketing around lithium batteries has been so effective that people now assume battery always means electrochemical cell. But that's a definition problem, not a physics problem.